Hello, everyone. Welcome to our session today of, excuse me. Welcome to our session today of Meet the Young Professional. And as you know, we are inviting the senior young professional members who were once associated with the IEEE Bangladesh section in this series. So I'm very happy today to have with us Dr. Imran Mohammad Amin. Dr. Amin has completed his PhD from the Monash University, specializing in radio frequency circuits. And Dr. Amin has a lot of diverse academic and industrial R&D career on smart sensors, Internet of Things, future automation, and 5G technologies. He has recently worked in the Australian Communication and Media Authority as a radio engineer. And today we are going to listen from him what's the steps an engineer should take for his career in the 2020 situation. So without further ado, I would like Dr. Amin to share his presentation with us.
Thank you, Sajid. It's really good honor to be present in such a audience, and it has been, to be frank, it has been a while. I have been talking on career guidance and also talking in IEEE gatherings because I have been a bit disattached with or from IEEE, I'd say. So when Sajid told me about this opportunity, I definitely wanted to share some of my views, but I would be frank because I'm just sharing my screen. I'm not sure whether you guys can see it. Can you?
Yeah, now we can see.
Okay, cool. Okay. As I said, like when Sally told me, I thought I just want to grab this opportunity and just wanted to share some of my views of how we can navigate an engineering career in 2020. First of all, I just need to put some disclaimers here. I think these all this who has joined here and who will be watching might be thinking it's a very serious conversation, but I really want to make it a very casual one, and that's intentional. What I mean is I don't want to really make it very technical. And as I go along with this presentation, I wanted to take this opportunity to just share my experience I had throughout the last, I'd say, 10, 12 years in my career, starting with my, definitely my graduation from BUET, and kind of reflect on what I taught, what I learned during this course, and the main findings that I think it's important and might be useful for students who just started for engineering course, particularly with electrical and electronics engineering, as well as the young professionals. So it's just a story of myself and my learning, and which I find interesting and also useful for my fellow mates. And these sort of, I would say this is kind of a mentorship presentation with which I kind of share with a lot of my mentees and as well as people whom I advise. So that's why it won't be a very serious conversation, and I just wanted to make it like that. Firstly, when to start with, as I said, like I just wanted to share my story as well, just to let you guys know where I am or where I'm from, essentially, because it's really important to understand where a speaker is coming from, because I find myself having a bit of diverse career background, though I'm in my middle to getting a bit more senior in my career. Firstly, I started off with the school in Dhaka, and actually this is the photo, and you'll see Sajid is standing beside me, so he's my schoolmate. So we have been in Udan school for quite a long time. And then I definitely joined BUET and graduated from there, was a lecturer for, I'd say, less than a year. had an opportunity to go to Monash University in Australia. Definitely, there was a number of reasons to go there. One of them was a topic in particular. I was basically told to work on some printable radio frequency identification and RFID sensors, which really paved the way of getting into more communications and radio propagation. Definitely, as we all are from our BUET graduation, we don't have a very specific specialization. If you know what I mean, we kind of go to our masters or higher studies or PhD, and we start specializing in a particular area, and that was the case for me. And I started loving it to some extent. And one of the milestone was I had an opportunity to go to the MIT in Boston and study there for 6 months as a visiting scholar, and it was it's a very good journey, and I learned a lot. I'll definitely share some of my learnings from there. Not the technical parts again, morely it's gonna be a non-technical. Then the main industry, because I worked at Monash as some research fellow, did teaching there, but I wanted to kind of move into more industry. And my first industry experience was working with the Radio Frequency Systems, RFS, who is one of the, they do all kind of communication stuff, starting from mobile, satellite, and then I was mostly working in the broadcast. Broadcast means TV broadcast. And some of our systems are in the One World Trade Center and Sears Tower, and I'll touch a bit on that as well a bit later. Now, currently, I'm working. It's an interesting area, and I'll have just one slide on that as well, just because people who are from communication background, they might know a bit about this area, but it's a very niche area, which is we call the spectrum engineer. So I'm working with Australian Communication and Media Authority, which is basically a regulatory body for managing the spectrum. And you can say, like, if you know, in USA there's the FCC. In the UK, there's Ofcom. In Bangladesh, we have the BDRC. So we are a similar body who works by the guidelines of International Telecommunication Union, ITU, and we regulate the spectrum. But why I'm being a PhD holder in RF and microwave engineering, ended up in a spectrum engineer in an agency. That I also will be sharing. So so the summary is, and that's where I'm going to today's presentation. So I just wanted to walk you through what I've been learning throughout this whole career, and what basically makes me an engineer. But I think it's my views, and definitely there are different views, and what I learned. So how I look at it is, this whole career journey is a bunch of I say a bunch of skill sets and experience. So end of the day, you have these all very combined, complex skill sets that you start acquiring, and you keep acquiring as you go in your student and in your career path. And then and also with the skill sets, you have the experience, which makes you a unique person to move into your next career. And that's basically becomes a unique point. And if you say in terms of when you go to a job interview, what you're bringing in the table. So this is you bring in the table. So your skill sets and experience. That's how I see. And the skill set I acquired from every single point, every single job, or every single assignment I did throughout my career. That's important to keep in mind. So what's to expect from my talk? So I'll definitely try to break down what of some of the engineering skills, like when I say engineering skills, so what to be an engineer in the first place? What skills do you need to become an engineer? And you just Google it, and you're gonna find there's a lot of resources. They say, okay, so if you want to be a good engineer, you have to be an expert in maths and physics, whatever. And then you're going to say you have to have a good understanding of the engineering concept. You have to be a good problem solver. You have to be good. You have to have the good attention to details. You have to be hands-on and those sort of things. Definitely, there are multiple. Sorry, I'm just checking the chat if there's any comments. Yep, sorry. So definitely there are a lot of skills that's already known out there. But what I wanted to break down some of the key skills which I find very important for my case, and also wanted to share here. And then about an engineering career in general, like for an engineering career, what's the typical path, and what can be the other paths, what can be the alternate paths. That's something I wanted to share. Then I'll touch a bit about entrepreneur because that's the buzzword nowadays, and then also a bit of looking beyond engineering. That's it. It's gonna be very long, and you just want to make it. It's not working. Okay. Yeah. Okay. Now, first, it's back to basics. What we learn to be an engineer. Now, that's, I think, always when I start talking about these topics, I always want to go to the fundamentals and start to think what actually makes us engineer, because this is always important to keep in mind. And from my experience, when I was at MIT, it kind of I kind of revisited this issue because this is the old logo for MIT. Now they changed it, but they have something in the logo which my supervisor at MIT, who kind of explained it to me, and I really like the point is, and it's every engineer should keep in mind that mens et manos. If you see here, it's called mens et manos. What it means, mind in hand. And you see someone is reading a book, and a lady is doing some work. So what it essentially means that, and engineers are someone who not only reads but also does something, makes something. They have an outcome or have an output. So which really reflected to me and really inspired me, because when I think of an engineer as a profession, so it's not only a knowledge that we just learned. It can be knowledge from science centers, as you can see here, or any other knowledge, particularly science. We all try to apply it. We try to make it more hands-on, and we try to have an outcome. So that's a fundamental thing that always we as engineers need to keep in mind. And when I was talking with my supervisor at MIT, he always stressed that, like, this is very important as you go to your career. And I think we all who is engineers and we are with IEEE, we know that, we understand that, but it's always try to remember that and reflect on that. Now, when we talk about this applied knowledge, engineering as an applied knowledge, what does it comes to our mind? First of all, it comes that we have to be more hands-on. And the first thing comes as from my experience. And when I talk about my experience, I'm talking about like similar background to me, who has done bachelor's from universities like Bangladesh and Southeast Asia, and also and definitely traveled through across the world, or still maybe working in Bangladesh. We have a bit of I'd say stringent, and we have a bit of reluctancy on hands-on. And a lot of cases, if I can remember, a lot of units, a lot of courses we did when we were studying, we had these sort of things in my mind. Oh, it's engineering is hands-on, but we don't have the opportunity. We don't have the right resource to make it hands-on. So I remember a lot of cases. What happened? We ended up just solving mathematical problems. You know what I mean? For example, we started off with KVL and KCL, Kirchhoff's law, like circuit theory, and then we moved on to communication theory, Shannon's law, and control theory. Then like Maxwell's equation for me, because we learned it, and everyone, I think, agreed, like we didn't have the fortune to do everything hands-on. Now, that's something I think when we talk about, because now I have I graduated about 11 years ago, or more than 10 years ago. Now things have changed a lot. So first of all, I want to say to young engineers as well as students particularly, that you cannot always say that you cannot make things hands-on, because there's a lot of simulation tools out there which essentially can be an alternate to your hands-on. What I mean, like a lot of theories that you learn, you can examine that. And when I talk about simulation tools in particular, definitely there are, like, I started using Tinkercad recently. If no one has used it, they should start looking into Tinkercad, for example, which is from Autodesk. And this is an excellent tool, because I started using Tinkercad to teach Arduino to some of my students that's a different, for a different course. And I was really blown away the power it had, and it's a free software. So why I'm saying that, because this is really important, and also for countries like Bangladesh and those areas, Southeast Asia, a lot of companies, they give out free licenses. And I want to mention whoever is from communication background, like we all know, there's a simulation tools like computer systems technology, or CST, or HFSS, FECO. These are really powerful tools which is used in industry, and I have been using it. But they also have some student versions, which you can use to learn a lot of stuff which you have been studying. So what's my summary is, hands-on does not mean you have to be practical, like in terms of you have to have that resource and facility. There are other ways to make it. So that's something really we need to keep in mind. That's number one. Second thing, what I recently come, not only from my whole career being an engineer working in an industry, but as well as I now like mentoring a lot of young engineers, as well as teaching in different subjects like IoT, like Arduino. I know that in particularly I was talking about engineers coming from our background. We sometimes we sometimes lose the sense of inclusiveness. Okay, what I mean by that, for example, I'll give you just some small brief examples. If we can mute ourselves, that'd be good. Brief examples. We have done these like circuit theories. We have solved a lot of big giant problems for Kirchhoff laws. Like, but how many times that we have applied them in our daily lives? And I know it's not easy to apply this theories in our daily life. But for example, have we ever thought in the home that we all live in, what's if you try to think of what's the current voltage relationships, or what's the how much wattage actually we are consuming, and what's every single component is consuming, and try to get an overall idea of what's the actual current bill that's coming, or what's the overall supply demand in our, I'm just giving an example, in our household, or in a small part of our household. Have you thought of that? Sometimes we have done some projects, but we haven't really thought about the actual house that we are working. Some other examples can be, so we all not for electrical engineers, but for other engineers, like for example civil or structural engineers. So we have made or studied the theories of structural engineering, but have we really thought of making, for example, a simple furniture like a table or a chair? Not only making a table or a chair, it's a carpenter's job, but if I say you have to make a table or chair with certain load conditions, and these are the standards you have to make. So why I'm saying that, because these are really important, that whatever we study, try to implement them in real life and think of what's happening in real life. That's really important. And my next slide, I'll try to explain a bit more from a real life example which happened to me, and it really changed the way I started thinking of an engineering career. So I'll move on, and I think might be difficult, but if anyone has any questions, they can raise their hands and we can take a floor, because it's not very serious conversation. Now, in my whole industry career, I just wanted to share this one because this gave me a lot of learning about what actually means to be a very young engineer, and this was one of the main projects. So I was working in RFS, as I said, radio frequency systems, and they're one of they do a lot of communication devices. So I was working as a design engineer, but my section was working the broadcast components. When I say broadcast, these are high power equipments, and when I say high power, it's because it's for UHF TV. They are like at least 50 to 80 kilowatts of power they burst from the transmitters to the antenna, and these antennas are at the top of the buildings, like as I said, One World Trade Center. So this is one of the systems that I was the main design engineer, and I did the full design in CST and other simulation tool, and we definitely did the manufacturing. So I actually, it's a small manufacturing farm as well. So we did the manufacturing, we did the testing and everything. So it's a really nice, like for engineers, it's a nice way to do the whole project and make things and build things and test it and as we say, hands-on. That's not the topic. Why I pointed out this particular project, as I said, like this definitely was a challenging project. There was the expectation from customer. There was a lot of design challenges in terms of how much power it could handle. So definitely there were previous designs. So my job was to modify some parts of the design to make it more robust, cost-effective, manufacturing friendly, and mostly it was it could handle more power. Now, as I said, the interesting bit was, if I think of what I learned from this project and what was the main challenge for me, it wasn't actually the part like which was my part in terms of doing the RF design or the simulation, because definitely I had the resource, I had the mentorship, and I had the skills to do it. But the things changed when I started building stuff, and it's very interesting that being an RF engineer, and whoever works in RF or have a bit of experience in RF, it becomes very tricky because every single component in a system reacts to the radio wave. And it definitely depends on the frequency, but in this frequency, you see it has a lot of long screws, as well as it had to have heat sinks and a lot of other components. And when you have to think of the other components, not the actual device. So these are cavities, like as you can see, these are cavities, which is just waveguide cavities. But you have to somehow manufacture them and screw them up and make it a big structure. And then every single screw or every single component or heat sink, and also the color of the cavity, every single thing matters. Now, what I wanted to go over that is, I come up with a pure RF engineering background, and I had my PhD, so like I knew my stuff. But when I went there, so I had to work across my boundary. As you can see from here, I had to work a lot with the industrial production engineers, as well as the manufacturing engineers. And I had to spend hours and hours trying to learn from them what needs to be done to compensate a lot of problems, and then it had to incorporate in my design. And that's a key learning which I found is when we as engineers graduate from a particular school like electrical or whatever, or we have done higher studies, we before going to the industry, we think, oh, I'm this engineer, so this is my kind of box, this is what I do, or this is my desk, this is what I do, I don't go beyond that. But it's really important to understand what's happening outside, and as the quicker you learn what's and communicate with the other, definitely within the engineering disciplines, and try to grasp that knowledge and try to incorporate that, then you make things faster and you kind of move on faster. And that's what's I'd say needed, and that's what expected, and this is really important. And industry expects you to be the engineer, not just one engineer working in a desk. So you have to be the engineer trying to collaborate and try to go beyond your, like you're not, so you're not just only design engineer, you work with across the other parties. And sometimes I had to spend a lot of time with these test engineers, like the engineers who is working in fabrication, and trying to learn what the methods they are using, because how they make the stuff can and the tolerances they have, I had to incorporate in my design and see what that tolerance can do to a system like an RF design. So like I know those who are working in industry knows better, but for the young engineers, that's something really important to keep in mind. So you have to have these like adaptability, trying to learn new skills, technical skills, as I saying in these cases, and also just having the yes I can do attitude. That's really important, that I think being a young engineer has to have, and that's expected when you go to any industry. And I'm talking about from my experience being in manufacturing industry, definitely there are other industries as well, like telecommunication industry and other universities, and they have their own challenges. But this is something I think across any industry, this is important. Um, as I move on, I wanted to show a bit more about organizational structures, and we'll talk about engineering career path in general, because that's also something I learned, and I think it's important in some aspect. Typically, I have seen, and in a lot of cases as well, engineers working in a engineering firm or engineering company, they normally, as you can see, they normally tend to work as a design engineer or a systems industrial engineer. So they want to be with the engineers, and they want to go to the senior engineer or a principal engineer. At best, they go to as they when they get promoted, they become an engineering manager or maximum project manager. That's really good, because this what a person or engineer is looking for, and he's passionate about engineering. That's fine. But in some instances, and from now on, from the next couple of slides, I'll move into a bit different topic, and that's why I wanted to start this conversation here. So some cases, and being in a mid-sized company, I had the opportunity to look at the whole vertical of the organization structure, and I think that's number one important thing which I want to give it to any young engineers and students when they're moving to a company. Always try to have a good understanding of the company organizational structure. That's I always do, how the different layers. It's not only the engineering teams who is working and where you are in, but also the other streams, like manufacturing can be the stream, and also definitely the areas where normally engineers don't want to go. What I mean is sales, marketing, finance, and then HR, and also what's the CEO of the company is doing, like how he's attached to the company. So this is really important. Just try to understand the bigger picture of the company, how it's running. And definitely for my case, being a project manager after in the last stages of my staying in the company, I had a big bird's eye view of the whole company I was running, and it created an opportunity to delve in different areas of the company, not only being an engineer. If I want to go from engineering to, for example, sales or marketing or product development. Product development is an area where it can have different names, but product development or product development basically means what are the new technology firms should adopt, looking more into the future. So what I mean in this slide is, for an engineer, it's really important to look beyond the capacity and try to find out if there's anything else they have interest. And this is something what I feel sometimes we as an engineers we miss, as we sorry, again, I'm just, yep, as we are more used to doing our day-to-day life jobs, We don't look at the organization structure overall and where I might fit after, not now, maybe 5-10 years. So that's really important to have an overall bird's eye view of the company, of how the different parties are working. Especially, I had opportunities to work with the business development manager or sales in particular, and I had the opportunity to meet with the clients and with big clients like Telstra, and negotiate with them. So this gave me a really opportunity there, and definitely my fellow salesperson who was from our company was also from an engineering background. So I learned a lot of things from them, how the organization started and how we deal with the clients, and that's gave me an immense interest in working in other areas as well. So this is, I think, very, very important, starting from the young engineers as well, just to look beyond your ability or your team, not only engineering, but in the non-engineering areas. So at this point, I also wanted to mention an interesting thing is, it's not maybe common, and I don't think it has been common in Bangladesh, but in countries, definitely in USA, Australia, and a lot of other countries, in engineering, when students graduating, a lot of students do a major in maybe in engineering, but they do minors in other areas, for example, in a business or in accounting, and maybe finance, and definitely sometimes they do cross engineering skills. But having a dual skill like a business and in engineering, there has been a lot of studies and statistics that shown the employers find it very positive about someone who has a bit of a dual background, because they can flip them in different areas. Like they can go from banking to other sectors, or within any sector. For example, an engineer is working can work in a bank because he has the skill sets of an engineer, as we said, and as well as he has some background in other areas of business or finance, and then he can move around. So this is, I think, also really important to keep in mind, that creates a lot of other opportunities and industries like that. And again, as I said, like end of the day, we never know where our interest lies. So this is really important to keep in mind as well. Now, I just had this slide before, a couple of more slides where I talk a bit more on some different areas, spectrum engineering, because I thought, because I'm coming from a communications background and there might be some people in communication, just I wanted to give a brief of what we do as spectrum engineers in a regulatory body, and why I be having a PhD in communication and working in a design firm, and like why on earth would I want to work in a government agency who's dealing with spectrum? Now, there are a number of reasons that I think, and when I joined there, I found there are a lot of PhD holders, not only from engineers, but also like law people, policymakers, people from media, and other people have joined, and they're working. It's a very nice environment, but again, it depends on the interest, because not a lot of people know about it. That's why I just had this slide. So spectrum management in general, what is it? So spectrum management is basically, I want to mention this part because one of our very senior directors mentioned about it. Globally, International Telecommunication Union, ITU, does spectrum management. So they have their regulations, and mostly every country is mostly follow, because it has to be a harmonious spectrum across the world, because of this whole interference issue. But what he said, spectrum engineers or regulatory bodies globally, what they do, they take a product or service which is spectrum, which is essentially free for everyone, and what they do, they actually make it a kind of a product and sell it to companies in billions of dollars, and the companies pay for them, and they create revenue from those companies for the government. So what I mean is, essentially it's a free product. If you think spectrum, like it's free, yeah? But somehow they make it and a standard, and create a product or whatever you want to say, and put some policies and regulations on it, and make it make it a product and it's auctioned for billions of dollars. And interestingly, Spectrum, the branch that we or agency we work, they are the third highest revenue generator for Australian government, which is interesting. So they generate this much of amount of revenue just managing the spectrum as well as managing the media in general. So this is very interesting to know that how you can generate revenue. So the first of all, one of the main reasons what I found here interest, definitely being an engineer, I work in the spectrum engineering, so we develop documentations, we do coordination, which is more technical stuff. We look into the interference issues and different services, and when we think of spectrum, we just think of mobile phones, but spectrum is for defense, satellite, mobile phones, and wireless broadband networks. And there's so many things that use spectrum. Definitely your Wi-Fi, Bluetooth, and anything falls under this. So you just need to manage it. But the main reason where I came from is we call it a spectrum planning. Planning means you look into the future and try to come up with new policies. Definitely having the underlying engineering basics, you have the policies to have a harmonious band. Like, for example, if you think of the 5G band that's happening or coming, a new 5G bands coming globally in different countries. So we are now working towards the next 5G band in millimeter waves and trying to think, okay, so in this band, who would be the main customers for this band and what they need, trying to get their needs and having those, if it's a products or frequency bands, such a way that to create competition in the market and as well as benefit for the overall country. So it's a very interesting, as a strategic position, as well as working a lot of with legal issues, policies, instruments, and we also abide by the Radio Communication Act. So I think it's a really nice blend, which I wanted to go and wanted to go beyond of just working as a design engineer, but know the whole spectrum of different services used in RF. So that's why I'm really enjoying it, though I just still a mid to senior engineer. So this is an area I think like one of this area, normally being a traditional engineer wouldn't find it very interesting, but because I had the opportunity to go beyond and had wanted to be in a more strategic position, so that's why I joined here, and I found a lot of other PhD holders as well, as I said, are working in this area. Now, two more slides where I just wanted to put some different perspectives, and I thought this falls under the category what I'm talking now. One is entrepreneurship or having a startup. I know this is a big buzzword nowadays, and we can see this huge number of tech startups coming globally. It's a global phenomenon, and it's true that a lot of studies have a lot of statistics have shown with the new technologies, for example, AI, Internet of Things of IoT, machine learning. The good number of products or revenues will come from startups, like small startups having new products and services, which will create the market and pave the way for new technologies. That's all good. Now, when we talk about this entrepreneurship or startup, it's all good, but I personally have some skepticism in whether it's good for everyone and anyone. You know what I mean? Because startups is a good way, and I'll talk about it, but there's actually doing a startup needs a lot of experience, mentorship, and courage, and a lot of things. So for young engineers just moving directly to startups, and I have seen a lot of engineers struggling to meet the expectations, because that can be a deterrent as well. So some people need to be aware of that. But the main point why I wanted to bring this slide is I'm not talking about being an entrepreneur, but I'm trying to point out the entrepreneurial mindset, which is really important for engineers, and that's why personally I think anyone who is an engineer at some stages of his life to have to think as an entrepreneur. You know what I mean? So why? Because apart from these engineering skills that we need, an entrepreneur gives you a number of skills that I have documented here. This is really important. I take it from Forbes, one of the articles. First of all, I think it's really important to have the strategic thinking part, because a lot of cases, as I said, like engineers lose this strategic thinking. So like when I say strategic thinking, it's not about you solve an engineering problem, but you think of what this problem can do to the greater society. Because nowadays, with being the engineering careers more complex, it's really important that the company or the organization wants any strategic decision boiling down to engineers, and in a lot of cases. For example, traditionally all the strategic decisions were taken upstairs, which is like the directors. But now engineers are also told to, okay, so give your opinion. What do you think about this product? Because traditionally engineers were, I'm just going to design a product, give me a spec, I'll design it. But no, now you have to go beyond that. You have to give your own comments about your strategic thinking. Or if you are participating in that strategic decision making, that gives you an upper edge which the other people might not have. So strategic thinking, strategic decisioning is something is really important, and it needs a lot of expertise on that. Definitely taking risk, it's really important. For it's not just a engineering skill, but it's a life skill. Taking new risks, thinking outside the box, this is also counts when you work as an entrepreneur or in a startup. Communication and networking, so that's also, actually I wanted to mention more about negotiation skill, because when you are an entrepreneur or a startup, you have the ability to not only have a good product, for example, but also you're trying to negotiate with whether it's your client or any other stakeholder or a venture capitalist who is trying to give you some funds or investments to or you just want to attract them. So you somehow want to sell to them, or you want to make your product good, and you know the features of your product, and you know the need for the client or the venture capitalist or for the investor. So that these are really important, like communication, networking, and negotiation skill. Having a good business acumen. I think a lot of engineers fail here, and I have seen from my experience as well. Like it took a long time to understand what does business do. When I say business acumen, means again going back to how an organization runs, where the different revenue streams, how to do where the profit is coming from, what actually makes a profit, so these things, so what's a cost justification. Being a project manager, I had to work in some aspect in doing a business planning for a particular project only, not a company. But I think this is really, really important, that and areas, if someone knows a bit more detail about understanding of what are the next technologies coming from, because the technology market is so diverse and so fast. If you don't have the business acumen, we have seen a lot of traditional technology companies have because they could not diversify themselves in the right time, in the right moment, has could not do profit, or had to detach. Definitely. Then finance and sales is definitely another skill. It's not only, you just technology is not like a lemon shop. People just come and buy lemon because everyone knows it's lemon, because it changes, it grows, technology grows, it advances, and you have new feature is coming up. So you have to be adaptive, and you have to know your clients and who wants what technology. So what's new, what's coming. So sales is very important as well. And I think as an engineer, have the ability to go into different areas like business, finance, and sales, because he can be, if they has acumen and has an interest, can highly, participate and as well as contribute in these areas in a company. And in this entrepreneurship, I wanted to share my own experience from MIT, because, and if I want to share something from my experiences at MIT, that's a hub of startup. How I saw it, because one of the reasons was in the group where I was working in a small group, but also met a lot of people from outside, like of our group in MIT. There were a few students who was working as a PhD, like a PhD student or master students. A number of them actually were entrepreneurs. What I mean, I'll particularly mention about one of the students, George, because he's worth mentioning. When he was doing his PhD, he already had 4 companies himself, because MIT has a culture like from your undergrad, you essentially the projects you do in your undergrad, if you're good enough, and there are definitely bright students who is good enough to know what are the needs of different companies. For example, he was working with first with Bosch, and also secondly he was working with Jaguar, a car company, and his interest was making small sensors for cars, like automatic cars. And then he, in his student life, he actually had products which he already sold to different in competitions in different venture capitalists, and got the money, and then made another product or prototype, and then made and sold it to different companies. So he actually had 2 to 3 at least companies before he graduated. And then during his PhD, he actually had funds from Jaguar for himself to develop a full car automation system. And interesting enough, if like when I met these people, I could know the difference with them, and personally I as well, because I didn't had any background in being an entrepreneur or having had the entrepreneurial mind. So I think this is really, really important, and it gives you some top of the hub skills, which is not possible to find in any other studies or experience. So that's why I particularly want to mention that. And interesting, again, as I said, I give the example of this particular person, Josh. He ended up being the assistant professor of Michigan State University, which is one of the reputed university. And if you think now, lot of now I need to mention, because when we talk about this entrepreneur or startups, particularly in countries like Bangladesh, we have a taboo of he's a startup, and most of the startups, like in student life, are run by, just wait to check my, sorry for that. Yep, you're good. So a lot of cases this startup culture is between the students or people who does not have a job, who has a very low CGPA. That's very interesting, and they think of, oh, I need to do a startup because I don't have anything to do. But it has to change. This mindset has to change, because these, as I said, like it's entrepreneurial is a set of bunch of skill set which is important for every single human being. It's not for people who's not really good at studies or whatnot. But and there are definitely good examples of some of the big people, really bright students has gone into entrepreneurship and doing startups, and have done excellent contribution to the community. So that's why we have to come out from this taboo. The number one. And second one is, definitely in Bangladesh, we didn't have the culture like in USA, where industries are very active and proactive in supporting students and those sort of things. But the culture is definitely changing, and if being in Australia, I can also say the culture is not as great, but it's changing. The last thing I wanted to say is, if you look into the lot of research and academic positions or tenureship positions for lecturers and globally in faculty members, one of the key determinant now they look for is whether a person or the faculty member has the ability to attract funds for themselves and to support the students. When I was in MIT, I was also told if I could gather some funds, I could get a position for like a postdoctoral fellow and in future. So what I mean is, like you see, like the skill of entrepreneurs, you really need it for your academic positions as well. So that's why it's really important to get the skills which is needed, and try to see how we can gather them. So I the next slide, looking beyond engineering, I wanted to kind of sum up with these couple of slides now, because now I'm just thinking of beyond engineering, and I want to propagate this viewpoint as well, because this is really important. In March 2011, when Steve Jobs, and he's definitely very popular to everyone, like tech people, when he was inaugurating the Apple iPad 2, he had a statement like, technology alone is not enough. It's technology married with liberal arts, married with humanities, that yield the results. And if anyone studies Steve Jobs and how Apple phones are designed, about the backgrounds, you'll know he not only thought about the technicalities or the specifications, like needing the spec, having a good battery life. No, he also thought about where gonna be the home button, how it should look like, why people will admire a phone. It's just a phone, but it's just cool. Why I'm saying sometimes engineers needs to study or go beyond just regular technical studies. There are other studies, for example, liberal arts and humanity, as he mentioned, and there are a number of researchers have been lately that engineers who is just studying engineering, maybe in IT, working in IT firm for 15, 20 years, generation, they are lacking creativity. A recent study from Rahul Chandra, Dr. Rahul Chandra, he's one of the strategists in the USA who deals with future tech education in India. He was telling there's a big need for students in India to go through liberal arts, and also there's another study from one of the universities in Japan, who they were looking into from 1960, when the Prime Minister of Japan mentioned that they wanted to make a tech hub. Like he wanted to encourage young students just to be economic and be more technical savvy. So after 4 decades now, what they can see, it's not helping as they thought, and the engineers becoming more departmentalized, and creativity is losing. And that's why a lot of university in USA now, they recommend students to take other humanities and liberal arts course. Why I'm saying that, because this is something I found is rarely taught in our school of thought, like being a Bangladeshi born engineer. And you'll see there are a lot of examples where people have taken the courage to come out from the bubble of this engineering and have changed the world. For example, like how many of us know, maybe all of us know, that Mark Zuckerberg, when he the founder for Facebook, his major in Harvard was psychology and computer science. So he actually read psychology. So why did he read psychology? And you can now see, after a lot of studies now, Facebook, he reads your like mine. He knew what's the need for Facebook is. And I was listening to one of the founder, one of the lectures from Ibrahim Kadir, who is the founder for Grameenphone. So he was also talking, and his background, he was a computer scientist, and then he moved to USA and he studied economics. So why I'm saying this diverse knowledge sometimes can make a deal breaker and give you some completely different perspective where you are. And this is really important. It's not for everyone, but someone who has the passion to take a different turn and see whether there are opportunities elsewhere. And definitely they can build on their engineering skills and experience and take it to the next level. And that's why I wanted to say the look beyond engineering. That's really important to keep in mind for young engineers and students. So as I said, end of the day, everyone's goal is landing in a dream job, and as a Forrest Gump says, and I always believe in that. Like, it's life is a box of chocolate. You never know what you're gonna get, but you just need to keep passionately pursuing for that dream, and at some stages we'll all understand it's not the salary or the monetary benefit that we're chasing for, but also the passion to drive is really important. And definitely the main thing that I believe is we just need to think big and think outside the boundaries, and not confine ourselves with just the engineering arena where we are working. So just some final thoughts, and for again coming back to 2020, it's one slide tells everything. If you want to get ready for tomorrow, like someone just starting engineering or just graduated from engineering, there are a lot of areas why I wanted to focus this last slide, like from the LinkedIn Learning, is you'll find these are the like what was the top 10 or top 20 hard skills. Like there's a list of skills, like you need blockchain, cloud computing, AI. So these are the skills you need. But in the same time, what I really wanted to focus is there is this soft skills like creativity, persuasion, negotiation, collaboration, adaptability, emotional intelligence, and some other things that I wanted to touch. So these are really important because end of the day, as I said from the beginning of my talk, is I see my whole career is a bunch of units where I gather skill or an experience that kind of helped me to get a better human being and a better engineer in my career. So I wish I could give you some benefit. And as I said, like I just wanted to have a chit chat or just share my own experience or make it a casual one, because I think you all are very good professional and very highly valued engineers. So if you guys have any comments, and I wish you have some more inputs to this conversation, it would be good. I wish you all the best, and I hand it over to Sajid. I can hear you, Sajid, you're muted. Sajid, you're muted. Can you unmute yourself?
Oh, sorry. Thank you very much, Imran, for the really nice presentation. And I think you have highlighted a very important point that we need soft skills as engineers. And most often when engineers go into the companies, so it's said that 20% of what you earn is based on your actual knowledge or your technical skill, and 80% of what you earn, it's more focused towards what actually is your soft skills, how you can manage people, or how you can talk to people, how you can work in a team environment. Those kinds of skills are extremely important to get. And I think we have 2 questions in the chat box. So since it's not too many, I would like to invite them to unmute and ask the question. So first question is from Samiha. You can go ahead and ask the question. Or okay, I'm not sure if she can hear me. I'm just. Oh yeah. Okay. Go ahead, please.
So my question is, how can I find any particular supervisor for my field for PhD in abroad?
So you're saying in your field?
Yes, sir. I'm from CEC.
So look, it's a very general question. So definitely what we used to do when we were looking into studying abroad, we definitely tried to narrow it down what are the universities we wanted to go, in which countries, and then we looked into the websites. The general way would be the looking into the website and try to find out the different professors and their expertise, and most of them have their team and their research very well written. So you can just email them and approach them. whether they have any opportunities for PhD. So that would be the very generic way that most of us, like me, and I think most of us here who have gone abroad has done. In other cases, there are a lot of groups nowadays, like BUET groups and other groups. They give you tips, or if there is anyone who is abroad who is looking for new students, they can give you some contacts that sometimes are really helpful. So yeah, so I think start off with definitely looking into the websites and try to find out whether someone's interest or any faculty member's interest matches with your profile or in the area where you want to pursue your higher studies. Yeah, that would be the first thing I would do.
But I have heard that sometimes they didn't reply the mails. So how can I convince them?
Look, it's a common problem because they essentially get a few hundred of emails, I'm pretty sure, every week. So it's difficult to get their attention. So there are a number of methods you can use to have a more.
Oh, unfortunately, not sure if Dr. Amin is disconnected, but I guess I can put my 2 cents into the question. So typically, a professor would receive anywhere from 100 to 200 emails from one in any particular day. That might be his grant meetings and all other particular topics. So it's very important that you write concisely to the particular professor, and you state clearly that you write only to the professors who might be also interested in your particular skill set or your expertise. If it's a both way situation, then you have a higher probability of getting an answer from that professor. But typically you also have to understand that you have to approach a number of different professors, and whoever has an opening at that time and who might be interested to hire you, they would also reply to you. So I think Imran is also back, so he can add more.
Yeah. No, thanks, Sajid. Sorry, my connection was lost. Yeah, so just to add, I think what Sajid said is very important. So you have to just write in a way that works for him as well. Not only he wants to know about your expertise, but his vacancy is important. So that's why sometimes what I found useful is directly writing to a supervisor or professor or faculty member, because he's busy, is difficult. You can write to his maybe research fellow who is working under him, or any other team members, and just to try to get an information through other medias, maybe LinkedIn, whether he has any vacancies. So these sort of things can also help, and try to be very concise of what you're trying to get from the supervisor also. This is very important. Yeah.
Yes, particularly I wanted to have another talk just for like academic or business communication. So I think this, particularly for email communication, it's something we can all work on to improve our skills, to be concise and just go to the point. So if you write a huge email of like 2 pages, I mean, no one has the time to go through the email. So he would probably just leave it in his to-do pile and never look at it. So I think we can move to the next question. It's by Nabila. So if you could unmute yourself and ask the question.
Sir, my major is in electronics. So I want to know what is the field of electronics in Australia, and how can I approach? How should I approach if I want to build my career in electronics? Like, should I take MS in, or should I just go into a job? How is the field actually?
Yeah. Again, it's a very big discussion, but I try to summarize. You can definitely communicate with me separately. If you want, like, I'll pass my email. First of all, in Australia, the easiest way would be getting a job sometimes gets difficult because they have some requirements of permanent residency. They look at it a bit more strictly. So most of the students who wants to come normally comes to masters in research or PhD. Unlike USA and Canada, in those universities, mostly the funds are by the faculties, sometimes from the school as well. But in Australia, most of the funds, a lot of funds are from the school, so you can directly apply to the universities directly. That's not a big problem. So there's the main universities like the Group 8. If you search for Group 8 at the main top universities, any of them you can apply and look into their. First, you just need to look into their electronics, electrical and electronics department, whether any suitable professor is there who kind of matches with your profile. And again, you apply directly to the online application. There's, I think, 2 rounds of application happens each year, as well as you can write to the individual professors where you want to work. And sometimes if they have the vacancy, as we just discussed, they they might reply. Yeah, and it's general. It's good. It definitely, the job opportunity. USA market is definitely bigger, more for electronics engineers. But in Australia, there are a lot of niche areas. There are very good opportunities. So again, it depends on within electronics which area you want to do or want to focus on. Yes.
Sir, I have a question. Can I ask?
Is there any
Sure.
other question from the audience?
No, sir.
Yeah, I think,
Sir,
I
I am
think,
Rajesh and I have a question.
Rajesh, could you speak up a little bit?
Okay, sure, sir, sure, sir.
sure.
Can you hear me, sir?
Sure.
Yes, now it's better.
Yeah, I can hear you.
Okay. Sir, I am Rajesh and I actually professionally working on Rovi Axiata as wireless transmission engineer. So I have a wish to do my PhD and post-graduation and thing. And currently I am working on the telco like for 3 years. And how can we cope with the new scenario? Like for the post graduation, what can be taken as a measure? And many of us who joined a job or professional scenario after graduation scenario, and they're like kind of stuck in the scenario. So how can we proceed to or pave the way to our post graduation thing? It will be a great help. So that's it. I hope you can get my points.
Okay. I think if I get your point, you wanted to ask because you have been working for quite a while. So you are working in the transmission, wireless transmission section.
Wireless transmission.
Wireless transmission. Okay. Look, there are from Robi and Grameenphone, there are a number of senior colleagues and also our batchmates who has come to not only Australia, in different parts of the world to do PhD. So I don't think that's a big problem. And to be honest, a lot of faculty members and a lot of schools look at industry experience nowadays very strongly. Sometimes we believe that industry experience is a deterrent to do higher studies like PhD, but it's never the truth. As long as you can show that you are competent, to do research and you have the research mindset, that's really important. So I think the best way would be, and you have to remember that from a fresh graduate who just did a bachelor's or just a master's, if you have a good amount of experience in industry, you should have a bit of more skills. Sometimes we think research means you just need to write research papers, and that's what faculty members are looking for, which is not correct always. Yes, research papers helps you to get attention from a faculty member because that's easily can address your contribution to the community, the research community. But having an industry background, you just need to show while you were working in an industry, how you have developed your career, how you have learned new skills, your ability to adapt, as I said, adapt to in new environment, new skills. Again, some things which is also important for higher studies, like project management, managing your time efficiently, creativity, and learning new things and expanding your knowledge. So when you write your SOP, if you address those issues, I think definitely it wouldn't be a big trouble for people working in telco. And you can go in different areas. Definitely, a lot of people go in which area I came is wireless and microwave engineering, but there are other areas you can move into, especially nowadays. Internet of Things or IoT is booming, and automation. In those areas, a lot of people need uh, uh, a lot of research is coming where they need people with wireless background or comms background. So definitely there are some areas you can also explore. So you have to do a good study on different faculty members. When I say faculty members, I mean the research of different faculty members, and try to fit where your expertise can fit. Also, they can have usefulness from your experience and skills. Yes.
Thank you, sir, for your kind answer.
Okay.
Thank you very much. And we also can invite Asfar Adib. So he's also a friend of ours who was in EEE Department of BUET. So he worked in Grameenphone for long, about 9 years. And then in 2018, he switched tracks to academia and then moved to Canada. He's currently doing his PhD.
Yes.
So, I mean, we can learn
Same
about his story in a future talk as well.
Saki Bhai, he was in Chevron from 08. He was in Chevron, and then he is in Pennsylvania State.
Oh, so that's wonderful. So, I mean, that's what part of this series is goal. So we want to learn from different people's aspect or different people's views on their careers and how they proceeded to either to industry or leadership positions. So is there any other questions from the audience?
Sir, I have a question. Can I?
Yeah, sure. Go ahead.
So my name is Devesh Mondal. Actually, I joined late because I was outside. I've joined just right now. Sir, I have been working in Energy Pack since 2013, and I have been working as a production engineer of power transformer. I have experienced of up to 300 MVA transformer manufacturing and with 230 kV system for this. And just few days back, I think few months back in September 2019, I have applied for my visa of 489 family sponsored visa in Australia. Hopefully after this pandemic, I will get my visa. So I have, my question is, like as a transformer engineer in Bangladesh, if I shift in Australia, how should I plan about my career, and what are the skills that I should develop before I arrive in Australia? I think you have understand my question.
So sorry if I got it. So you want to do higher studies in Australia, or
No, sir. It's actually temporary residential visa, sir. This is 489
okay.
state-sponsored visa.
I understand. Yeah. No, so you will have the opportunity to work, or you can do studies. Both you can do. In terms of power sector, first of all, you just need to remember when you have experience in Bangladesh, getting a job exactly in the same area or the same field, for example, in the power sector, might be possible, but also can be sometimes difficult, because if there's not any much of an opening in that area, so you might need to switch. So that's why what I would suggest, I normally suggest people coming from overseas like Bangladesh or any other country, try to have a broader view. Definitely your experience will be counted, like you have industry experience, but that doesn't mean that you have to limit yourself with only those areas. And you can move to other areas, for example, telecommunication, because telecommunication definitely is one of the largest areas because of the 5G rollout and NBN rollout in Australia that's happening. Then other area you definitely have to keep in mind is construction, like road construction and railway upgrades. These are big projects in Australia happening in all over Australia. In power sector, I personally don't know what are the, definitely there are big companies, SP Ausnet and other energy service providers who is there. But I personally don't know of what are the current vacancies or situation in general. But in Australia, what happens normally, government has a big projects for 5 to 10 years. Now, currently, the construction for rail construction, defense, government is putting huge defense budget for the 10 to 15 years. Then construction, as I said, and these are the
Well, sir,
major two.
I'm
Telecommunication.
basically
Yeah.
07 batch and electrical engineer.
Yes.
So, is there any special skills that I should develop before I reach in Australia?
In terms of special skills, as I said, like any skills that as okay. So if you now more specific. So I would say what you should do. You just need to in your case, I would do go to seek.com.au. If you haven't gone there, go and have a look into the different engineering jobs which is available, and try to see what are the requirements they say. If they say any particular certification for rail construction or defense, or you just try to see whether you can acquire that. It's always good to look into the job descriptions and try to see whether how much you fit in. You know what I mean? So that's
Yeah,
the
yes.
I would say the best approach. And definitely you can communicate me personally if needed, separately. I can share my details, or Sajid can give my details. Yeah, through social media or LinkedIn. You can
Okay. Thank you,
connect
sir.
with me.
Thank you very much.
Sure. Thank you very much. Yeah, I have given a link to a feedback form. So if you can fill up the feedback form, I'll just pass on to everyone with their questions and comments to the speaker. As well as if you want a participant certificate from this event, you are required to fill up the feedback form. And with the speaker's permission, we would first edit the video of today's presentation, and then if he agrees, we would put it up in our YouTube channel. So I've given a link to our YouTube channel in the chat as well. So I would like to invite everyone, if you're comfortable, please turn on your webcam. So we would like to take a group photo with the speaker. Okay, thank you. Okay, I'm just going to take the photo now. Okay, thank you very much. I've taken the photos. I will share the photo and hopefully the YouTube link in our YouTube channel, as well as in the Facebook page of our channel. So, I mean, with this, I would like to really thank our speaker, Dr. Imran Amin. So, yeah, we share a long history back. So, he and I, we studied in the same school, same college, same university. We even joined the Department of EEE on the same date. And then he decided to change tracks, and now he works for the Australian Radio Communication Agency. So with this, I would like to thank everyone for stopping by, and I would like to conclude this session. So thank you very much.
Thanks, Dr. Sajid, and it's a pleasure to be here. Thank you.
Thank you.